Hello, my name is Nigel Griffiths. I work in Power Systems Advanced Technology Support in Europe. In this video we'll be looking at Shared Storage Pools Phase 4, the theory and concepts. There's another video that covers some hands-on experience and you can watch me actually use it. This is also called SSP4 for short. It became available, I think it was November 2013. It's actually a feature of the VIOS server and the version 2.2.3 or above. I'm going to assume in this video that you are already familiar with Shared Storage Pools 3, so we'll be looking at the differences. I'll include a 2-slide reminder in a couple of slides' time, but if you're new to the Virtual I/O server Shared Storage Pools, then I recommend strongly that you watch the first 3 YouTube videos, and they'll get you started and up to speed. The last 3 videos here are showing some advanced functions that are now available with shared storage pools that you may not initially first think of, but are very useful and powerful. So let's get to the point of Shared Storage Pool Phase 4. We have a new feature that allows us to remove a LUN from the shared storage pool. Now you may not be aware that we didn't have this in the past, but we now have it, which is nice. The big new function is this pool mirroring option for resilience. It allows us to handle some disaster recovery type problems. Perhaps a whole disk subsystem has failed, has gone offline or switched off or something, or the entire site has gone, or we got just some other LUNs going offline type failures. Well, now this mirroring will let us work through that problem and keep all the disks up and available to the client virtual machines. This of course does double the disk requirement. That's typical of a disaster recovery scenario. The Shared Storage Pool 4 manages the actual mirroring of the I/O. That means it's not handled at the client virtual machine's operating system level, so we don't have to make any changes to the clients to put this new feature in. Also, the Shared Storage Pool 4 does all the silvering and recovery resilvering autonomically behind the covers. As soon as the LUNs become available again, it will do all the resilvering for you without you having to do anything at all. This is all managed by a concept called failure groups. We have 2 failure groups inside the pool now, the 2 groups of LUNs, and there's actually a fail group command for managing this. There's also much simpler shared storage pool commands to use, and this will help us in a usability sort of thing. We have PV for the physical volumes. That just allows us to control the LUNs in the pool. And the LU or logical unit, this is the virtual disks in the shared storage pool, how to allocate space and give it to particular client virtual machines. I often get asked, are my disks supported for shared storage pools? And the answer is, if it's supported by the VIOS server, then we're good to go for the shared storage pools. There's a URL here for where to go and find the datasheet to find out which disks are supported. Sometimes it will direct you to non-IBM disk vendors to give you a complete support statement. How do you get Shared Storage Pools Phase 4? Well, it's delivered with the VIOS server 2.2.3 and it's fixed backstore any VIOS server above that level. So either upgrade your VIOS server to that level or do a fresh install of 2.2.3. So here's the first of my reminder charts. Here we have the Virtual I/O server presenting virtual disks to our client virtual machines at the bottom here. And there's various flavors that we support. The simplest was the logical volume that's on a disk connected to the Virtual I/O server, and that appears over the Virtual SCSI as a smaller disk here. We can do the same thing with a whole disk and present that to the client virtual machine as well. Next in was the LUN. This is a HDisk, of course, as the VIOS server sees it, and it presents that as a Virtual SCSI device too. We then introduced a file-backed file system pool, which means we actually create a JFS2 file system and we create a great big, 32 gigabyte file, and that file is then presented to the client virtual machine as Virtual SCSI as well. The nice thing about all of these is that the customer, the client VM, just sees a Virtual SCSI device. It doesn't know what's behind the covers and he doesn't care. Next was the NPIV way of doing LUNs. This is quite different in here because the LUN isn't really presented and online in the Virtual I/O server. The Virtual I/O server is just passing the read and write and control information back and forth to the disk, and the client virtual machine has the disk online. It is talking here over the virtual fiber channel. This is a very different way of operating, and the Virtual I/O server is pretending to be a SAN switch in this case, just passing the packets back and forth, not really involved with the contents of the disk. Now the new one in town is the shared storage pool. So here we have more than one virtual I/O server cooperating in a cluster. It has this pool of disks. They are, in the end of the day, LUNs on the back end and on a disk subsystem of some sort. But all the virtual I/O servers are cooperating access to those LUNs. They then carve out certain blocks of disk space out of those LUNs and present that as a virtual disk, again over virtual SCSI to the client VM. Again, this client VM doesn't know what's behind the covers. That's hidden by the virtual I/O server. The nice thing is that you put these LUNs online to the virtual I/O servers once, and then you allocate space using the virtual I/O servers, not having to make changes in your back-end disks or zoning across your SAN. Here's my simple view of the architecture of shared storage pools. At the bottom we have some SAN disks. We've cut out some LUNs and we put those into this thing called a pool, out of which we're allocating chunks of disk. Think in terms of 64 megabyte chunks. We create all this shared storage pool just once. We'll see some management features of it in a moment. But we just do that once, and then we go to the VIOS server level, and here we do our space allocation and mapping to our virtual machines. This all happens at the virtual I/O server level. We log in as pmn and just run a command, or we can go to the HMC and run a graphical user interface to do the same operations, and these operations take less than a second. The VIO servers then are operating as a cluster, and they have concurrent access to that set of LUNs in the pool, and of course they have to cooperate so that they actually work well. They then cut out a piece of disk space, for example the blue set down here, spread across the LUNs, and that's presented as a virtual disk. It can be thin or thick provisioned. That provisioning is done by the VIO server, and it's presented over the virtual SCSI interface. This is just a little reminder about Shared Storage Pool 3, where we can add a LUN to make the pool larger. We add in this extra LUN. The Shared Storage Pool software will move some of the disk blocks to that new LUN to make sure that we're using all the LUNs to do the I/O and spread that out across the maximum number of spindles available. Also with Shared Storage Pool 3 we could do a replace LUN option. So if we had a LUN that we wanted to remove from the pool, we could give it a new LUN. It would copy all the blocks from this LUN onto the new one and then release this LUN. As a side effect, we could use this operation to move all the disks that are on one disk subsystem to another disk subsystem, so it will migrate to a different disk subsystem. So here's the new function. We're going to remove a LUN from the pool. A fairly tricky operation. We have to decide all those pieces of the disk that we're actually using at the moment. They have to be copied over to the surviving LUNs, and we have to do this while the clients are doing I/O to them as well. And we have to sort of cross our fingers that it'll actually fit. If we're using all three LUNs and they're nearly all full, then of course we can't shrink it down and it will refuse to do it. So now let's turn to pool mirroring and failure groups and how do they work. Well, the client VM is only going to see one copy of the disk. It does one write. The mirror is completely invisible to it. It means there's no admin work to do on the hundreds of clients. Really good move to keep the manpower down. The VIO server will do all the hard work. It will actually do the I/O to the two copies of the mirror. It also understands the LUN state, so if a LUN disappears and comes back, it understands which bits of that disk have to be resilvered and gets on with that magically in the background without involving any of the client virtual machines. This new failure group then allows us to do this. Inside the pool we have these two sets of disks, probably on different disk units to give us the redundancy, and the whole pool is mirrored. It's not done on a logical unit or virtual disk by disk basis. It's the whole pool is either a single copy or two copies in mirror. By default, when we create the cluster for the first time, we have a default failure group called default, which means there's no mirror. Then we can add a second failure group, and that puts in the mirror for us. We can rename default to something else if you want to. So let's go back to our architecture diagram. Here we have just the first failure group, and we've got one set of disks in here. We're going to add the second group. Then we're going to have the VIO servers copy all of the blocks in the current LUNs over to the new set of LUNs, probably at the bottom here on a different set of disks to give us the redundancy we want. Now let's have a quick look at those three new SSP4 commands. As a quick overview, we have the failure group. This adds the mirror copy. We can create and remove that extra copy, list it and modify. Well, you can probably guess what they do. On the PV, the physical volumes, these are the LUNs inside the pool. We can add a LUN and remove a LUN. We can actually add and remove them in pairs, for example. One of each LUN would go into the two different failure groups. We can list and replace. On the LU command, this is the virtual disks. We can create and remove them. We can create and map them in one go, or we can use the map and unmap commands to break the connection between the logical unit and the client virtual machines. And we can run a list operation to have a look at what we've got. So a few notes on these new commands. There's optional parameters, minus cluster name and minus storage pool. They're totally pointless because we only got one cluster and one pool at the moment. So there's no need to use them at all, and I'll leave them out of the examples. Will be more important perhaps in the future. The failure group and PV command have an optional minus file name, and in that file would have a list of disk names separated by white space. And if we got lots and lots of LUNs or H disks that we want to specify in the command, we could put them into a file and give them that way. For me, I only have about 10 different LUNs that I'm using with my shared storage pool, so I just put them into the command line. That's up to you. Again, I'll leave that option out. If you have massive numbers of LUNs, then it might be worth exploring that option. There is a bit of a command overlap. The failure group command is completely new function, so that's new. The PV command is a superset of the change storage pool add and change storage pool replace command. As it's easier to type in the PV command and it has extra features, I think everybody should move over to the PV command. The logical unit command, LU, is a superset of the make backing device from storage pool command, and the change backing device from storage pool command, and the remove virtual device command. And again, it's easier to use, and so I think most people should move over to that immediately. We'll be using the LU command every day as we create and detach virtual disks to our clients. The PV command will use that now and again, maybe on a 3-monthly basis, to change the size of a storage pool, for example. And the failure group command, we'll probably only use that once when we initially set up our cluster. Now here's some notes on the LUNs. Shared storage pool expects those LUNs to be rated, probably RAID 5, but it's not enforced. If you're using 2 failure groups for disaster recovery, if you lose a mirror, then you're back down to 1 copy, and you want those to be reliable disks, so don't use JBOD. The pool size will be the size of the smallest failure group. The extra space in the large failure group can't be mirrored, so it can't be used, so it's just ignored. This probably means it's a good idea to keep those failure groups the same size. Probably a good idea to have all the LUNs the same size and the same number of them, so that will work out nicely. And when you add or remove LUNs, remove them in pairs, one from each failure group. That will keep them the same size. Now do note though that it's not a 1-for-1 LUN mirroring. Just because you add a pair of LUNs, one to each failure group, don't think those 2 disks that you just named, HDisk30 and HDisk40, will be mirror copies of each other. The shared storage pool can decide the contents of the LUNs, and they will not be directly mirrored 1-to-1. Now let's have a look at those 3 commands and their lifecycle diagrams. We will still be using the cluster create command to give us the initial cluster, to add new nodes to it, and to create the initial shared storage pool on a single set of LUNs. If we want to handle disasters, then we can use the failure group command, create, to add our second mirror. And these will be copied pretty quickly by the VIO servers. We can use the failure group list command to give us a list of how many failure groups we've got and what content they are and what's the status of the failure groups. We can use the failure group modify command. The only thing we can actually do here is rename if we don't like the name default. Perhaps we want A and B or something for our 2 failure groups to make them more meaningful. Finally, in 20 years' time, when we're dismantling our shared storage pool, we can use the failure group remove command. It can remove either of these copies. You're going to give it a name, so you remove either one of them. If we're operating the shared storage pool without a failure group mirror, then we have the PV add. This will just add a LUN to the pool. the shared storage pool will then be spread out across that extra LUN to even out the I/O across them all. We have the PV list that will list the contents of the pool and the state of the pool. We have the PV replace, we've already seen that, where we can use that to actually migrate the pool onto a different disk subsystem. At the top in here we have the PV list minus capable. This is a little bit odd because it doesn't list the disks in the pool, it lists the disks that could be in the pool. And by that we mean all of those disks must be visible from all the VIOS servers. Very good check to run before you actually put in a whole bunch of disks into the pool in one go, because you'll know that they're actually there and available. And this is the new one down in here. We can actually take a LUN out of the pool. If we are running with a failure group, then there are some little differences. The PV add, we can add a pair of LUNs, or 4 or 6 or 8, equally across the two failure groups in one command. The syntax looks a little odd, but we can still do that. The PV list in here, just to highlight the fact that you can list all the disks from one failure group or from both failure groups if you want. PV replace, because we've already said that the LUNs aren't paired up, we don't need to do a replace of two LUNs at the same time. You might as well just replace each of them as you go if you want to move the storage pool. The remove, again, we can remove a pair of LUNs, one from each of the failure groups. If we want to do that, that would actually make sure that the two failure groups stay the same size. And finally, but not least, the LU command for creating our virtual disks for our client LPARs. This is the option I tend to use most of the time. I create a logical unit of a particular size and use the V adapter to connect it to your vhost. That creates the logical unit of the right size and connects it to the vhost, and so it's available to my client LPAR. If you miss out the V adapter, then you can actually create the LU and it's just a piece of disk space not connected to a client. We can then use the LU map command to put in that link, and we can break that link with the LU unmap command. At the top here we have the list command. This can give us lots of information about all our logical units, how big they are, who they're connected to, and their sizes and their usage, and how big they are if they're thinly provisioned. Finally, when we're done with them, whether they're connected or not, we can use the LU remove command. It will break the connection if it's there and put the disk space back into the pool. Next we're going to look at the commands by example. We're not going to go and read the manual pages out to you and give you every single combination. We'll cover the bulk of what you'll actually need to do. There's another movie, of course, that will do some hands-on experience, and you can see me actually running the commands and see what happens. So we've got the three commands there for the mirroring, for the LUNs, and for the virtual disks. Assuming you have the shared storage pool running and it has three LUNs in it, how do we actually make a mirror? Well, here's the first example: failure group create. Failure group, this is the name of the failure group. And notice this colon here, and then these are the LUNs. So we'll run that command and it'll go off and add them to the storage pool and start the mirroring all for you, completely automatic in the background. Here we have failure group list, and so we can see we have the default group, that's what the initial set of disks are called, and it's now V7000B. It's degraded in here. You read down the bottom here, it's not yet fully got the mirror complete. When that happens, it will just be online next time you look. Later on we decided that the default name was a bit ugly, so this is the only modify option we have here. Failure group, we name it and we change the attribute to be V7000A, and when we list it now we say the two failure groups, giving us some clue about which disk subsystems we're using. There's online offline is when you have a complete failure group. I guess this would be a disk subsystem failure, or maybe you've lost some major switch connections or something and it's lost one set of the mirror. Very much later on, maybe never, you'll run the failure group remove command. The two mirror copies are equal in importance, so you could just name either one and you'll get rid of that particular mirror, and those HDisks will then just be freed up and available for other use. All of the commands have a list minus fields option, and then you have the names of the fields in here, and so you can limit what's actually output. We also have a format delimiter character, so we can make the output easier to parse in a shell script, for example. And the minus header here will give you a little heading line in here so you can remember which column is which. We won't cover these in the other commands, but a similar sort of thing happens there. Well, that's it for failure group. Literally, you want to create the mirror with the LUNs to match the current shared storage pool. Then perhaps we want to use the list command now and again to monitor it to make sure it looks okay. In the PV command, a whole bunch of more options in here. We'll look at those now. Up the top in here, if we don't have the second failure group, so there's no mirror, then when we can just add more disks to the shared storage pool, there's just one set of LUNs. If, however, we do have a failure group, then we need to typically add a LUN to each of those failure groups. So this is the command to actually do this. Add -FG for the failure group, and again we're using that notation for the name of the group and a colon. Then we have a list of disks, and then the name of the second failure group and a list of disks or LUNs to be put into that failure group. So be careful with that syntax. Those colons are important, and I think it will just complain if you don't get them right. When we're taking disks out, of course, it doesn't have to be matched up failure group for failure group, but that would make sense. Take a LUN out of both sides of the mirror at the same time. We've had a similar command with the change storage pool, but now it's the VP replace, so that will take out this disk by copying all the used blocks on it to the new disk, and then this will be freed up for other use. Very nice command in here for the finding out what LUNs that are available on the current VIOS server that are also appear and can be performed I/O to in the other VIOS servers in your cluster. So, of course, on the other VIOS servers they may have different HDisk numbers, but this gives a list of these are the possible ones we can actually use now. These UIDs are pretty good. These two numbers here are my two different V7000s, and this number in here is the LUN number as we see on the V7000. Just very quickly, we go to the V7000 administrator panel and we can see these numbers are here. We go back. So we have the 22A8 and 54 here, and here we can see the 22A8 and the 54. So we can match them up very quickly with our disk subsystems. There's also a list option. We see they have the name of the storage pool, the name of the failure group, V7000A and B, and then we have the disks attached to each of the failure groups. The status here is online. That's good. There are other statuses for the LUNs down here: online, stopped, failed or missing. There's also the UDID. Unfortunately it cuts off the end because it won't fit onto the screen. If we use the verbose mode, then we get the full details of that, and it also puts in a description. We get a paragraph for each of the disks, and it says here that it's an IBM 2076, which everybody knows is a V7000. Let's move on to the LU command. This is the one that we'll be using all day, every day, as we connect virtual disks to our clients. The first option up in here then is LU-create. Give it the name and the size, 16 G for gigabytes, M for megabytes. Then the V adapter. This is the virtual SCSI client adapter that goes to the virtual machine. If we want, instead of thin provisioning, we want thick provisioning, then we're going to put -thick at the end. I'm always going to smile when I type in that option. We can do the same operation in two steps. So the first line in here, without the V adapter, just creates the disk space without attaching it. And then we can use the -map option, tell it which one we're interested in, and this will do the connection to the client adapter for the virtual machine. We can do the opposite and disconnect from a particular client virtual machine, so we just have the space available with the unmap option. Finally, if we no longer want the disk space, we can use the -remove, just give it the name, and regardless of whether it's mapped to a client or not, that will be dismantled and the disk space put back into the pool. Be very careful with this last option, LU-remove -all. That removes all your virtual disks in one go. The pool is then empty, so be very careful with that one. Here's two more slightly more complicated examples. Normally when you create a mapping, it gives you a virtual device name that looks something like this, vSCSI, and a number that keeps getting incremented. You can, however, specify what this is called. In this example, we just added the -VTD option and give it a name, and now this is what we get when it's mapped in. We can then do things like unmapping via that name, and then we could remap it to a different name if we wanted to. Also, we can use these great big UDID numbers, these great big hexadecimal numbers. I can't see this being popular. Very difficult to type in. I guess you'd cut and paste these if you wanted to actually use them. And we can use that in the remove option as well. There's one particular case where you do need to know this. You can, if you want, have multiple virtual disks with the same name. Here we're doing a remove operation on orange 42, and it's saying, well, hang about, there's 3 of them with this name. Which one do you actually want to delete? And then you'll use the UDID number to actually specify which one you want to delete. Could get a little bit complicated. Be careful of this one by accident. Sometimes you may want to do this. Maybe you're going to use your LU names just to be the same as your logical partition name and just have multiple disks that way. Just like the other commands, there's a -list option, and it provides you a list of all your virtual devices. Here we can see how the names, how big they are, how much is used. Be careful with this one. This is a thickly provisioned one, and of course all those blocks are allocated immediately. If you add the -verbose flag, then you get some more information about your logical units or virtual disks. Things like percentage and space and how much is unused. Type of provisioning, thin or thick, and some more information in here. We can ignore these things called tiers there for a future release, I think. I created a snapshot on this guy so we can actually see the names of snapshots that are available in here, and your guess is as good as mine for what these other things mean. Don't forget this LU operations of creating space and mapping it to clients can also be handled on the HMC graphical user interface. We look at the virtual storage management, then we can create a new virtual disk, for example, give it a name. This is the pool we're taking out of, size, and which client we want to connect it to, thin or thick provisioning. Then if there's more than one VIOS server, they appear here. And once we click the OK, it's done a lot of work for us. We can see the new device that's been set up for us. The equivalent command will be running the LU command in here. It will work out the vhost adapter, so you don't have to do that. And if you clicked on more than one VIOS server, then it'll go to the other VIOS servers and run the equivalent commands there to get you dual VI server support. That comes to the end of our movie looking at the shared storage pools, phase 4, theory and concepts. Don't forget, go looking for that movie where I do some hands-on content and you can watch me use it. Once you get the concepts right, you'll find that the actual commands are very easy to run and understand. You'll be able to find that movie on YouTube /nigelargriffiths, that's my channel. On Twitter, I use the Mr_nmon ID, and I tweet a couple of times a week on the important things going on with Power, VM, Virtual IO Server, and AIX. You'll also find my blog at this tiny URL /AIXPert.